everybody, we're getting ready to do Algebra 2 8.4, graphing ellipses. And if you missed out on the prior assignment, Part 2 and Part 3 for the PowerPoint video and the worksheets and the tests and the quizzes, email me here and you can get those. 8.4, class worksheet of 30 points, and then we have a huge note-taking guide here of 35 points. If you need note-taking guides, email me. Teachers, here's your bell work here for your students. Modified Mercalli intensity scale. Suppose an earthquake has 6.0 at its epicenter, 5.7 rating 50 miles away from the epicenter, and 5.1 rating 35 miles away. Represent the situation described above using circles. What can you predict about the Mercalli rating 12 miles west and 16 miles south of the epicenter? Students, give your students 5 minutes, 6 minutes to do this. Okay, we're back. Here is the graph that you should have gotten, students. Here we got two concentric circles here. And then when x equals -12, y equals 16, we plug this into our formula here. Because 225 is less than 400, less than 625, the rating will be between 5.4 and 5.7. So it would be in 5.4 and 5.7. It must be in this ring here, this area here. Okay, graph and write equations of ellipses. You graph and write equations, parabolas, and circles. You will graph and write equations of ellipses. An ellipse is a set of all points P in a plane such that the sum of the distances between P and two fixed points called the foci is a constant. So we have foci here, focus, and a focus here, D1, D2. So the sum of the distances between P and two fixed points is called a foci. D1 plus D2 would equal a constant here. And this is unique. So we have an ellipse here, we have focus here, we have focus here. This is our major axes here. This would be our minor axes here. Vertex, vertex, co-vertex here. The line through the foci intersects the ellipse, so this intersects it at the two vertices. So we have vertices here, and then we have vertices over here. And then this would be our equation of an ellipse here, x squared over a squared, x squared over a squared, plus y squared over b squared, y squared over b squared, would equal 1. Its midpoint is the ellipse's center, so joins the vertices. The center point here is called, it's like a circle. The line perpendicular to the major axis at the center intersects the ellipse at the two co-vertices. These are the co-vertices here. Co-vertices. This would be the major axis in this ellipse here, so it's wider. It's wider this way than it is this way. The ellipses all have a horizontal or a vertical major axis. This one has a vertical major axis. Okay, students, in your own words, define an ellipse and a foci here from your previous class worksheets. Define vertices and define major axes here from your class worksheets. Identify center, or rather define center and define co-vertices there. Define minor axis, students, define that as well. Okay, standard equation of an ellipse with center at the origin. This is a class worksheet. So equation, major axes, vertices, co-vertices. So here's our equation here. Major axis will be horizontal, because it's leading here. The x squared is leading the equation, so that means it's a horizontal major axis. The vertice plus or minus a and co-vertice plus or minus b. and then x squared plus b squared plus y squared over a squared. So now our a squared is underneath our y squared. That would be a vertical major axis. Our vertices would be 0 plus or minus a, and then our covertices plus or minus b. The major and minor axes are of lengths 2a and 2b respectively, where a is greater than b and b is greater than 0. The foci of the ellipse lies on the major axes at a distance of c units from the center, where c squared equals a squared minus b squared. And that is our lesson on first part of our 8.4 lesson on ellipses. If you want part 2, part 3, I think there might even be a part 4 in that lesson, email me here for that. And if you need worksheets, note-taking sheets, tests, online tutoring, email me there as well. Thank you.